I'm inviting our next speaker, just newly defended new doctor, PhD. Congratulations again, Grzegorz Nehring, that everybody is telling me call him Greg, because nobody knows how to pronounce Grzegorz. And I understand exactly. We have already heard about all these wonderful things about different types of iron-gall ink, vitriolic or non-vitriolic, that we are going to hear about today from Grzegorz, who spent his PhD working on Torah scrolls and types of ink which were used, and probably many other manuscripts, as we can see from just the publications that were mentioned until today. So Grzegorz works as well in BAM, and he's going to talk today about characterization of non-vitriolic iron-gall inks used in medieval manuscripts. The floor is yours.
Thank you so much. So in my talk, I will talk about more problematic inks, the inks that we hardly can distinguish. So first of all, just to start again with the ink types, we have iron-gall inks, which are products of a chemical reaction between iron two ions, and tannins with an addition of the binder. The most common iron-gall inks, the vitriolic iron-gall inks, are produced with use of vitriol. Vitriol is as a source of iron ions. As we can see in this little photograph in the middle between the three photographs, we see a picture from a mine where vitriol was collected. We see all those different colors, and all those different colors represent the different metal sulfates which are present in such a vitriol. Comparison of such inks is therefore rather simple when we look at the elemental makeup of such an ink, because they differ based on those vitriols used. However, when we look at the non-vitriolic inks, the sources of iron are rather, they contain no impurities. They are rather homogeneous. When the metallic iron is used, or other minerals such as iron phosphate thickened, which I present in this slide, the makeup of such an ink is really relatively unique. First, let us look at this scary table of elements to the left. In the central part of it, we have, I highlighted the most common vitriolic impurities that come from this salt, from vitriol. Manganese, cobalt, nickel, copper, zinc, those elements are very helpful for the comparison and determination of different types of vitriolic iron-gall inks. We basically look at the ratio of those additions of those impurities to iron, which is always the main element, the crucial element for the production of iron-gall ink. In vitriolic inks, as Professor Rabin already mentioned, we also have always sulfur, which comes from the sulfates, potassium, sometimes calcium. On the other side, we see that the non-vitriolic inks contain basically just iron, sometimes some manganese as an impurity from other minerals, or from metallic iron. They can contain phosphorus if another salt was used for the production of ink, and potassium from the binder or the tannins. I'll speak about tannins a bit further on in my presentation, but the sources of tannins were not always gallnuts. And now, with the addition of another tool to our protocol, which Professor Rabin already mentioned, we can say a little bit more about that part, the organic part of the inks. You already received a little introduction to the µXRF. µXRF technique, which gives us information about elemental makeup of the material which we are studying. In principle, with µXRF, we collect a spectrum, and in the spectrum, the energy informs us about the elements which are present, and the intensity of the signal gives us an idea about the abundance of the elements present in the sample. One of the tools which I love using, and I've been using a lot throughout my PhD and previous works, is an imaging µXRF. Such a device moves the probe, as you can see in the image, over the area which one is investigating, and collects spectra, such as the one shown in the middle of the slide. And first of all, we determine the area which we want to scan with such a device. And each pixel in the area which we are scanning corresponds to one spectrum of such. And then after a complete scan of the area is collected, we can display the whole area scanned as a map of elements. In this case, I'm displaying a small, relatively small map of elements, of two elements of iron and zinc, which are mirroring the shape of the letter which was scanned in this fragment. Just to give you an idea how much time takes, it depends on the setup of the equipment. However, for the big scan, which I was showing in this little video, we collected close to 750,000 spectra. So it's the points, and each point takes some time to collect. So it can be a couple of hours or dozens of hours, depending on the size of the area. Which here we had 5,000 spectra, which is a very, very short span. Now, with this information, let us go back to the study of the God's name, which was already introduced by Nehemia in his previous talk. Because with the use of the imaging XRF, we were really able to, first of all, strengthen the theory and give run-through arguments for his hypothesis. First of all, we look at the two spectra, and this is the common, the two spectra. On the top, the spectrum of the mining, and on the bottom, the spectrum of the God's ink. Just a little spoiler, we found that the composition of the ink from the corrections and the God's name was the same. So let's just skip this for the further part of this presentation. The difference between those two spectra is very small. We see only a tiny little bit of copper present in the God's name, which is not present in the main ink, and the ratio between iron and zinc to iron was not really giving us much information. However, since we used an imaging XRF, we were able to produce maps of elements. And let us focus now on what we see here. When we look at the maps of iron and zinc, we basically see two mirror images. Therefore, it doesn't give us much information. However, when we move to the map of calcium, we start to see some interesting patterns. We see two black areas where the signal of calcium is much lower, now encircled in red, where the corrections which Nehemia was interested in studying has been introduced. And in white, I highlighted the areas where the God's name was supposedly added. Now let's move to the map of copper. And in here, if we look at all those areas, we see that first of all, the God's names were definitely added to the text. And the same with the corrections. Now comparing all of those information together with the information about the same elemental makeup of the inks from God's names and corrections, we clearly see that those were first of all added, but more than that, the God's names were added together with corrections that's been introduced in those areas with the reduced amount of calcium encircled in red. Our hypothesis, it was master scribe was correcting the scroll, and while correcting the scroll, also filling the missing names of God. In this case, clear example that those were added. However, this technique is also very helpful in studying inks which, as I showed in one of my previous slides, contain no significant vitriolic impurities which allow this kind of comparison. First, we look at the spectrum from not Elfus7, as it was in the previous case, but a scroll from the private Hungarian collection. And we see an example of vitriolic iron-gall ink with zinc and some copper in it, a typical iron-gall ink. Comparison of those is simple. However, when we look at vitriolic, non-vitriolic inks, which we found in this manuscript, it becomes problematic. We cannot really look at ratios of elements as those just contain iron. However, as we can see from this spectrum, we see that the ink in the middle, in comparison with the ink in the top, it contains a different intensity or different amount of iron. This led us to proposing a method of comparing such inks of very uniform, similar composition. Here we're looking at a small dropout of one of the scans that we conducted on this Hungarian scroll. In the 4 lines numbered are here to help us follow what we revealed while using imaging XRF and using the way of presenting the data as heat maps. By heat maps, I mean that where the signal is stronger, the abundance of an element is higher. The color in the map displayed is warmer, and in contrast, when it's darker or colder, simply there is less of this element. If we look at the areas between the second and the third line, we clearly see that the calcium has been removed from the substrate, which fits well with the different handwriting of those two lines, the second and the third line. However, if we look at the upper border of this area, we see that while removing those two lines, the scribe was not very much good. He removed portions of fragments, the tiny fragments of the letters from what is here labeled as the first line. Let us look now at the map of iron, and whether it gives us more information about what's happened here. First of all, we clearly see that the ink from the second and the third lines is written with an ink which contains much higher abundance of iron. Therefore, it's displayed as much warmer and brighter colors. Especially, it's a striking example if we look at the third line where we see the letters appearing in red, and the red was set as the highest end of the spectrum of the abundance of this element in this case. Moreover, if we look at the fragments of letters in the first line, the fragments which I mentioned that were mistakenly erased together with the other lines, we can see how those fragments of letters were, in this case, added. More than that, when we look at the crowns, we see that all of those were also added to the existing text. In this way, even though the inks basically contain the same elemental makeup, we clearly see how those different stages of writing is being executed. This technique, in cases like this, requires a couple of hours to perform a scan. However, such a scan can be performed on a much bigger area with a slightly worse resolution. By resolution, I mean we select the size of the pixel and the time the device spends on collecting the information in such a pixel. In here, we see an area which covers, let's say, almost complete column and fragments of two other columns. In this big view and the scan, which took slightly more than 90 minutes, we see how we immediately see all the places which being corrected, highlighted in the heat map of iron. And also we see first of all, we see the changes to the letters themselves, but we also see that some fragments being heavily corrected. Let us look at the small area which is highlighted in red. What we see here, we see that the scribe who is correcting moved this one letter over here, and it's also mirrored in the, even though it's, first of all, this is a lower resolution scan, therefore we cannot read the letters which are here expressed in this black column. However, where the dark blue column, however, where the signal is higher in red, we clearly see how this message has been moved. More than that, we see how some fragments here of the text being corrected in the lowest line. Let us move to the final example of heat mapping helping in investigating text in the same case of the Hungarian scroll. When we compare the visible image with the image in the bottom, even though that the text looks really uniform, the hue or the color of the text is identical. The size of the letters, however, in the first and in the last line differs greatly. In this case, we focus on those. Let us first focus on those two portions of text. In the bottom, we see that at the end of the line, the intensity of the signal clearly corresponds with the fact that it was added later to the original text, which is expressed here in this dark red folder. We also see that similarly crowns were added, and also this fragment in the lower line was definitely added. Let us move to the heat map of calcium to see what happened here. And in this case, the scribe was very precise in preparing this material for the correction. Not only he removed the original writing, he was very regularly and meticulously following the shapes of letter. Therefore, now we can see the original layout of this text. how originally as a closed section was transformed into an open section. Since it's with this technique, we can resample and we can play with the way we collected the data. I'm going here to show you the same map as black and white image, where we can clearly follow what happened in this little passage. First, if we look at the line, the first line on the top, we see how this encircled this mark in blue word was originally stretched here. We also see that the word in red box was originally here. More than that, if we follow the markings here, we see how a fragment of this letter was originally in the line in the middle, and in the end, the last section was simply stretched, was filling this whole fragment of the last line. With this slide, I'd like to move slightly from non-vitriolic inks towards the topic which was already mentioned by Professor Rabin in her talk, the presence of tannins, another crucial ingredient of inks, the organic part of inks. And as she already mentions, very difficult to identify and to compare. First, let's have a look again on already familiar to you chart where we see those two different types of inks. As I mentioned, to source the acids, the phenols, the phenolic acids for the production of inks, basically two different historic sources could be used. First of all, we all know gall nuts, and the second one, the tree bark, usually the blackthorn tree bark. What is interesting, the compounds which we can identify in both slightly different. One is full of hydrolyzable tannins, and the other one is full of condensed tannins. But how can we investigate those? How can we identify the presence of such? Especially in the case of mixed inks, where we have carbon, which masks the evaluation and using the photography in different wavelengths to see the type of ink. When we look at the plant ink, this is an example of a plant ink from a mock-up that I prepared. We see that the tannins present in such an ink are quenching the fluorescence, blocking the fluorescence of the substrate. So this gives us an hint about the presence of such. However, it doesn't give us answer what kind of tannins, or are they really present there. For this, in the course of my PhD, I worked on an addition of another technique already mentioned by Professor Rabin, mass spectrometry. That's not a solid analysis probe mass spectrometry, which is important because it's a rather novel technique which allows direct analysis of samples which can be collected and then measured in the laboratory without skipping the extraction steps. In this case, I'm showing a small fragment of a manuscript where I sampled the ink for the analysis with this device. If you look at the photograph of the whole fragment, we cannot see what was sampled. However, if we look at the micrographs, this is 50 times magnification, we see that some ink was scratched from the upper part of the letter. However, this amount of the sample, when we look, it was very generous in this case. I collected much more material as it was samples we could collect as much as we wanted. And to conduct the real measurements, we only need a couple of those little drops of inks to get meaningful information. What kind of information? First of all, to do the measurements, one has to insert the probe with the little capillary on which one collects the sample. In principle, it could be possible to collect it directly from a manuscript, but traveling with it would be very difficult. For this, we proposed a protocol in which we simply collect tiny bits of ink and close it between two panes of little glass, and then ship it or transport it ourselves to the laboratory. Then we insert it into the instrument. The whole analysis takes place, which is very fast, and we get the following information. In this case, we were able to identify gallic acid and pyrrole. The pyrrole is the smallest fragment of phenolic compounds that give us information, give us hint that hydrolyzable tannins were used for production of such an ink, pointing towards the source of gallnuts for the preparation of this. On the other hand, in some other instances of inks and our mockup samples, in cases of condensed tannins, which are very generously present in the tree bark, for instance, very common source of tannins for inks, we see catechol or other derivatives of condensed tannins. We can, using this method, differentiate among those two types of inks. Unfortunately, we cannot say what exactly tannins were introduced as tannins degrade rapidly. And yeah, we only see small fragments of those big molecules which were initially introduced there. To summarize my little presentation, I prepared a list of conclusions that I'd like to present to you. I hope I proved how imaging XRF is a powerful tool which can help answer different scholarly questions. Further done, I'd like to stress that not every iron-gall ink is stressed on vitriol, as we know now from the results of our investigation and also our studies of mock-up samples. The µXRF and displaying the data as heat maps helps us in visualizing those fragments and sections that were corrected or written with inks of very similar composition. And finally, using the mass spectrometry technique, which I quickly mentioned at the end of my presentation, we can finally distinguish between type of tannins that was used for the production of ink. We are very thankful to all the people who participated in this work at different stages and at different parts of this research. And I thank you for your presence and attention today. Thank you.
Thank you very much for this brilliant presentation. And I invite you to ask questions, please.
Hi, thank you so much for the wonderful presentation. Very, very fascinating. I have a couple of maybe basic questions. Maybe I've been exposed to too much alchemical literature, but the vitriol in alchemical literature is sulfuric acid. And in these presentations, we hear that it can be iron, that it's a type of iron. So I want if you can clarify what.
Okay, so no. I think you might have, as we see this surprise here.
Oh, yeah.
No. Vitriols are hydrated metallic sulfates of metals. So it's a totally different compound.
Because it's a type of metal that you talk about.
Yeah, it's a water solid. Do we have something to write? No.
No, you can get it from a desert.
Okay, but
It's salt.
it's basically metal salts.
Okay.
No.
It's salt. Just
Can you raise it?
They grow like stalactites. You know how stalactites grow? Also, this thing.
I cannot see anything.
It doesn't have much.
It grows like a stalactite or stalagmite,
Okay.
exactly the same way. And this is it. The stalactites are carbonates, and these are sulfates.
I see.
You get sulfuric acid at certain point, but it's not.
Okay, interesting. The second question was, is there any sort of damage from all these zapping, all these?
No.
So this is
So first of all,
non-invasive.
not the second part. At the very end of the presentation, I showed how we break the limits of the non-invasive analysis. Here, in this case, we need a couple of little particles from the ink for this analysis. However, for all the previous study, it is non-invasive, non-destructive. We are not even in touch with them.
May I comment, just a very small comment before? When you speak about XRF, which is a common tool and which is laboratory tool, it is not, it doesn't make any damage. However, if someone invites you with your document to go to synchrotron, it can be damaging. There you have to ask questions, more questions. But nothing that is presented here can cause damage to a document.
Please lower energy. There are two questions. Leo first and Mark later. Yeah.
Thank you. Explain towards the beginning of the talk with the copper analysis, where the names of where the names of God were written and the corrections.
Is this God?
I didn't understand the.
Sure. Let us go through this quickly again. Is this the one?
Where there's a black shadow. That's
I like in the lower left, in the top like this, so
Yes,
you see black in the red, but
exactly.
you don't see black in the white.
Yes, this is the thing. So this area corresponds with what already Nehemia was showing in his presentation. So
Yeah.
this seemed to him to be a correction, which we truth to be a correction, and in white we have the God's name. The corrections are here introduced over area of the amount of calcium being reduced in the parchment. By reduced, it was scraped off. If you scrape the parchment, you reduce the amount of this element in the parchment. Therefore, it appears
Black is coming from scraping.
from the scraping, yeah, from some mechanical action, yeah.
But the whites, there was no scraping.
No, because they were left blank for
The
the.
inks were the same, so they show up in the lower right with the copper.
Yes.
Okay.
Yes.
Okay.
So basically, the ink, like when the scribe went through like correcting this scroll, he added also the name of God.
Yeah, I understand that.
Yeah. In this case, scribe used a different technique for removing the text. He was following the shapes of letter with some probably very sharp tool. As he also removed the calcium, which is one of the most abundant elements present in parchment. Therefore, in the negative, we can here read what was erased here.
In the negative here, are you seeing the remnants of the ink, or are you
No, we see
you're seeing the absence of the
absence of calcium.
parchment?
If you look at the scale, at the very bottom it's black. There's nothing, and we see that there is no calcium in those areas.
Mark,
Why is heat map called heat map? Or maybe you said I missed it.
It's just the term you use when displaying any kind of data, where you use a different color scale, and heat maps are for color scales where the higher the content, the abundance of whatever you're presenting, or the number, the color is warmer. Simply.
thank you. Arthur?
I'm not asking about the ink itself, but the use of the analysis.
Yes.
And I'm wondering, this question was when you were mentioning the so-called tamim, decorative lines like above certain letters.
Yes.
And, I don't remember all the laws and how you're supposed to write this, but is there anything about the thickness or the composition that speaks to time? That says that this was done before that, or, you can say, well, this was erased, and we see the absence of parchment or something. But is there anything that your analysis of spectra can tell us about time in terms of the writing?
The writing. So, let's look at this small area here, for instance. We see that the main ink, the original ink, is expressed in this dark blue color, corresponding to low abundance of iron in this case. The addition of those crumbs is expressed in a brighter color, corresponding to the fact that it was added later to the original.
So
It's a different stage.
Just how do you conclude that they didn't just shape the letter and then immediately add it?
Well, this we cannot say when.
Yeah, well, that's what I'm asking.
No, this we can, because in this case, you have this typical makeup of one ink. Now, you add something which is very thin.
Yeah.
It will be even colder in the color.
If it was the same.
Because if it were done in the same, because the crowns are very thin and they don't have that much ink, right?
Right. So you can't date ink, but you can say relatively this is, it might have been 5 minutes later. It could have been a day later, but it was later.
Yeah.
Or it was 100 years later, right?
This wouldn't be the day later. This would be some
No,
time later.
it's
because this-
unlikely, but
No, but your example is sort of visually clear because you can see that there's something happening and that something very different is happening. But this is as a spectral analysis. You gave me a very interesting answer. I don't want to talk
This
more.
is exactly the point that you have suddenly in a very thin ink. If it is the same ink, it would be written in the same type of the ink.
Yeah.
It would be even colder in a color because you have less iron there.
Yeah.
However, if you take ink that naturally has much more iron,
Yeah.
that's what you see, and it cannot do it at the same time.
Yeah.
It's a different name.
and in this case, what the correction is, they're changing a closed section to an open section. So this has to do with the dissemination of Maimonides lists and all that.
Uh-huh. Thank you very much.
More than that, this also gives us one other hint about the process of writing. We can see how, in some, well, the previous example was better, but even here we can see how the intensity of iron drops is reduced towards the end of the letter. We can see how, in some instances, we can see how the tool was dipped and then used for writing. At which point the scribe was.
And you see the periodic changes
The
of
periodic
the thread.
changes. I think it's
This
better
is-
represented here, actually. If we look at dies, for instance, there is periodic changes where the scribe is running out of ink and then introducing more
Judith, if you
iron.
want to teach doctors. This is the
I
very
guess-
Very interesting. What I am, on the previous image, what is really very interesting is that you can see that the flags of the lamet were also added with the
Yeah.
lettering.
Should I go back to it?
Yeah. So you can. Yeah. And I wonder whether it's regular, whether he did it all the time, or
Well,
that means that the
this is a
initial
retake.
shape of the letter was completely
Yeah,
different.
it's connected with the
Islamic was
correct-
really-
It could be correct.
That actually
The
erased
whole line was raised, including the head of the llama.
So he
Yes.
was, as we can see
Yeah.
here, he erased the head of it. Unfortunately, in this case,
Yeah.
it was accidental. So,
Right.
but yeah, we can assume that the person who, in this case, we can talk about the person because it was a person who erased this. Probably the same person fixed it.
Yeah, exactly. That's what I mean. That was
Can I
it.
just make one
Just
comment?
Really quickly, if you could like add this to what you're publishing so that when I look at it again, then I, just how to read it like like an X-ray would be really helpful. So
It is.
oh, it's already there. Okay.
This one is.
And it was cited in Nature. So I just want to say
Unfortunately, okay. You have-
one comment, which is that I feel like a medieval villager, and these are wizards. I mean, this is no, really. You can read the word a dome that's been erased. This is incredible.
Yeah.
But then we did by 3 different methods.
Yeah, unfortunately, I really have to stop this discussion. Thank you so much. It was brilliant.